We are going to see rows diagrams. Suppose a crustal block got faulted and one block moves past the other, creating lineations, what is known as the striations. Or imagine a river has flown in the past and has left certain paleoflow directions in terms of primary sedimentary structures. I have already discussed the primary sedimentary structures in a separate video where the paleocurrent directions has been explained. In such cases where a line is marked on a surface and the possible one or two directions are there, then we use the Rose diagram to represent them. Rose diagram is also called circular graph, and we will see why it is said so. Consider a rectangular area where there are 31 lines marked. For example, this is line 1, this is line 2, this is line 3, and it goes up to 31. I have intentionally chosen 31 number of short lines so that we are not dealing with small number of data set. Consider this is a geographic north direction and this horizontal one is basically a horizontal surface. Suppose these 31 lines are to be presented in terms of a diagram which is convenient for a geoscientist, then we will be going for a Rose diagram. First, the geographic north direction is to be understood, which can be found out in the field using a clinometer or a Brunton. I am going to plot line 1's trend. How to do that? Extend the line 1 and I have to find out from the geographic north direction clockwise how much is this angle. What I am asking is to find out angle between geographic north and given line in a clockwise direction. This is the most common way of presenting the trend of the lines. Now, with an angle measurer, I can find out how much is the angle, and it is 145 degrees. If one geographic direction, this direction is 145 degrees, then the other geographic direction, this direction will be 325 degrees. But here I will be writing in the table 1 only this value 145. Values which are 180 degree or less than that will be written down in this column, in this table for the 31 lines. Now, we can measure the trend for line 2, line 3, line 4. In this way we have to continue. Let us take line 5 and how we are going to measure. Students sometimes commit mistake even on this measurement, and that is why I am showing. This is geographic north direction. This line is parallel to this side of the rectangle, which is parallel to that side. So, parallel to this line, if I draw a line, this is geographic north and line 5 can be extended. Now, I have to measure the angle between the geographic north direction, which is this direction, and the line. So, this angle is to be measured. This angle is not to be measured, this angle is not to be measured, that angle is not to be measured. So, I emphasize angle between the geographic north and the given line in a clockwise direction to be measured. Now, with the angle measurer we find out the angle is 80 degrees. So, for line 5 the amount is 80. If 80 is one geographic direction of the line, the other direction is 80 plus 180 degree is equal to 260 degrees. But as I said, here I will be writing values which are either 180 degrees or less. For some reason I have entered only 80 degree. In this way all these lines 1 to 31 to be measured accurately and written down in the table. Now, just to revise, let us look at line number 18. How do I put an entry for 18 here? This is the line that has been extended. This is the geographic north. Clockwise from north is this angle. No other angle I am asking. That angle is an acute angle will be entered over here. And what about line 19? This is the geographic north direction. So, this angle, which is an obtuse angle, is to be plotted, is to be measured and written over there. So, suppose all these angles have been measured accurately and written in this table. Now, consider that after accurate measurement with the angle measurer, we have found the trend of line 1, 2, 3 and it goes up to line 31. Note that all the numbers are less than or equal to 180 degrees. Now, to create the Rose diagram, we have to create another table in this way. Trend range in degrees 0 to 30, 30 to 60, 60 to 90, 90 to 120, 120 to 150 and 150 to 180. You can raise a question why 30-degree interval is taken. You can also raise a question why I am starting from 0 degree. These will be explained after the first Rose diagram getting created. Now, for line number 1, the strike is 145 degrees. So, here I give a cut and 145 comes within 120 to 150 range. So, here is a tally. For line number 2, it is 149, which will plot here. 175, I have cut this number and I have put a tally over there. Do not try to search from here 0 to 30 how many numbers and then put the tally. That is not the way. Then at the end there is a chance of making mistake. Line 4, 62 degree, so I have given a cut and tally will be here. Line number 5, the trend is 80. This 80 is plotted within this 60 to 90 range. Line number 6, 127, which will come over here. Line number 7, 39, it comes over here. Now, in this way we will keep on cutting the numbers from this side and we will be putting the tally. As you know, if the number of tally is already 1, 2, 3 and 4 and you want to add a fifth number, you have to give a cut. So, this automatically means 5. We will not write 1, 2, 3, 4, 5. Why? Because when we are going to count them, counting these lines can create a mistake. So, it is so easy to see, say 1, 2, 3, 4 slash and 1, 2, this means 5 plus 2 equal to 7. Whereas, this number can be problematic to count how many tallies are there. So, I have almost finished this table, but there are two important situations for line number 19 and for line number 31. The numbers are 120 degree trend and here also 120 degree trend. Now, here is a problem where to put the tally, because I find 120 is there and also here. So, here we can choose any one of the ranges. Suppose I choose in such boundary situations, I will always go for the upper one, then 120 one tally over here and second one is being done. Suppose I got a number 150 degree. Now, what to do? I have already decided when it was 120, I have gone for the upper range. I have gone for this range 90 to 120. So, in that case, if 150 is found between 120 to 150 and 150 to 180, I have to go for 120 to 150 and put a tally over there. So, if I give a cut here, one tally will be over there. This was not the information picked up from the starting diagram, so I did not put a tally. Now, I have to convert this tally into frequency. I count them and it is 3, here it is 3, here it is 7, here it is 5, here it is 5 and here it is 5 and 6, 7, 8. Now, if I add up these numbers, the total has to be same as the total number of lines with which I started, and the number was 31. In case I add and I find that the number is not matching with the total number of lines, that means I have made some mistake. Now, these frequencies will be converted into equivalent radius. Radius of what is the question? That also will be revealed in due course of my drawing. To find out the equivalent radius, find out f max. Where is f max? That means the maximum frequency, the number is 8. So, I write this as f max. In this table 2, with the kind of data set we started, f max occurs only once, but it is quite possible that f max can occur more than once. This number 8 can be over there. Suppose this number is 8 and this number is 4, then the total is 31, then f max will be identified at 2 places. F max can be at more than 2 places also. In my case, it is a single place where I am getting the f max. Note that in this table 2, all the frequencies, the numbers are more than zeros. In my case, f is more than 0, but there is a possibility that depending on the starting diagram, I can get f I for some I equal to 0. That means, it is quite possible 30 to 60 degree range we were not having any of these 31 lines. It is possible, but this is not the case here. Even if I get some zeros once or more than once in the frequency column, that is also okay. Now, in order to find out the equivalent radius, the purpose I am going to explain, I have to choose the f max. Now, I will be consider f max is equivalent to, not equal to, that is why I have not given the equal to symbol. F max is equivalent to 6 centimeter. Looks like a mystery, why I took f max, why I am comparing it with 6 centimeter. Again, please be with me and things will be explained. We are going to draw half circle of 6 centimeter radius and we will proceed. Now, before that, if f max is equivalent to 6 centimeter, that means if 8 frequency equal to 8 is equivalent to 6 centimeter, then this 8 will be replaced by here equivalent radius in centimeter is 6. And what will be the equivalent radius when f is equal to 5? When f is equal to 5, it is equal to 6 multiplied by 5 divided by 8 is equal to, when f is equal to 8 is equivalent to 6 centimeter, then f is equal to 5 is equal to 6 multiplied by 5 divided by 8, arithmetic is done, is equal to 3.75 centimeter. 3.75 centimeter can be approximated as 3.8 centimeter. So, I write here 3.8 and also here 3.8. 5 is equivalent to 3.8, 5 frequency is equivalent to 3.8. What about f is equal to 7? When f is equal to 7, I do 6 multiplied by 7 divided by 8 is equal to 5.25 centimeter. 5.25 approximates to 5.3 centimeter. So, I write here it is 5.3. Similarly, when f is equal to 3, how much will be the equivalent radius? Again, f is equal to 8 equivalent to 6 centimeter, then if f is equal to 3, it will be 6 multiplied by 3 divided by 8 is equal to 2.25 centimeter. This approximates to 2.3 centimeter. That is why I wrote here 2.3. So, what I have done, I started with the trend values. From there, I went to create tally 0 to 30, 30 to 60. This was my own decision that 30 degree range I will be taking. And from there, I converted them into frequencies, and from these frequencies, I converted into equivalent radius, still without explaining to you why I have taken 6 centimeter as the equivalent radius. We are going to draw a half circle of the equivalent f max equivalent to so many centimeter radius. If I take this instead of 6 centimeter as 16 centimeter, then in my A4 copy the circle will go out, and also with the kind of compass I have got, I cannot draw 16 centimeter radius circle, and if I had taken instead of 16 centimeter 1 centimeter as the radius of the circle, that can be drawn very well within the A4 copy, but the problem is the finer divisions and the detailing of these works that I am going to do will be obscure. This fine detailing cannot be done in such a small circle. So, draw the half circle in a manner that it is not so big that it goes outside the copy, nor you draw in such a manner that the half circle is small. Note that we started the trend ranges from 0 degree up to 180 degree. Keeping that in mind, I am going to draw a half circle. Let us choose a 6 centimeter radius. I will further draw a line passing through the center and in this way, and mark this point as north and this point as south. Note that the trend range we took 0 to 30, 30 to 60, 60 to 90, etc. Keeping that in mind, I will be marking these angles at the periphery of this half circle, 30 degree, 60 degree, 90 degree which is east, and 120 degree and 150 degree. Of course, 0 degree or north is already marked and south or 180 degree is already marked. Now to do, here is the center of the half circle. I will draw a 30 degree angle. So, this is 30 degree. I mean to say that this angle is 30 degree. Next, I will draw 60 degree angle. So, what I have done? I have drawn geographic north on a horizontal paper, 30 degree north, 60 degree north, east which is 90 degree north, 120 degree north, 150 degree north and 180 degree north which is basically the geographic south direction. Now, we are going to see the equivalent radii I have already calculated starting from the first range 0 to 30 degree, and the number here is 2.3 centimeter. So, what to do? Now, on these radii that are drawn, this is the radii, I will plot 2.3 centimeter, 1, 2 and 3, 2.3 centimeter has been plotted. That means this length is 2.3 centimeter. From where I got this? This is the equivalent radius that we have calculated. Next, what to do? I have to take the compass once again, and from the center of the half circle I take 2.3 centimeter radius and draw only a segment between 0 to 30 degree. So, this is an arc of a circle 0 to 30 degree. Next, I am going to see for 30 to 60 degree range the number is again the same 2.3. Why? Because the frequencies were same 3 and 3. So, I have to draw the circular arc from here 2.3 centimeter, and this is 60 to 90 degree. In this range the equivalent radius is 5.3 centimeter. So, now what I have to do? 60 to 90 degree range, either on this line or on that line I will mark the distance 5.3 centimeter from the center. So, this means if this point is small a, this point is O, OA distance is equal to 5.3 centimeter. Now, I have to draw an arc of a circle with center as O and OA as the radius. Next, I am going to look at east or 90 degree to 120 degree, how much is the equivalent radius. 90 to 120 degree, it is 3.8 centimeter. So, on this line I will measure a distance from the center 3.8 centimeter. That means, if this point is small b, then OB distance is equal to 3.8 centimeter. Next, I have to draw an arc with OB as the radius, but restricted within 120 to 90. So, I am going to see 120 to 150 range, and here also same equivalent radius is found 3.8. Why? Because we see f or frequency was 5 for both 90 to 120 range and 120 to 150 range. So, effectively the equivalent radius is also the same, which is 3.8 centimeter. So, I will take OB as the radius and extend the circular arc. We are left with 150 degree to 180 degree range, and here F max was there and 6 centimeter is the equivalent radius. And interestingly, we started with 6 centimeter radius circle. So, here the arc will go like that. The Rose diagram is prepared. Now, a few things can be erased. What are the portions to be erased? I am not erasing, but rather I am marking with red pen. You have to erase these lines now. Now, if you erase these red portions, what is left to you is a Rose diagram. So, what has happened? The geographic data with various orientations or trends has been presented in terms of a Rose diagram or circular graph. Now, an instruction for the student: instead of taking 0 to 30 degree range, take this kind of range 0 to 20, 20 to 40, 40 to 60, and it will go up to 160 to 180 degree. What will happen? This table remains as it is, but this table will be cancelled. This is no more possible to use because here we use 0 to 30. So, on the same data set, you have to put tally, then you have to find out frequency, find out the F max, and then find out the equivalent radius r in centimeter. Once these are done, you have to consider F max is equivalent to, again let us take 6 centimeter. So, you have to draw a half circle of 6 centimeter radius and then draw the north south line. What change will happen in this Rose diagram compared to that one? Earlier we took 0 to 30 degree range, so we plotted north, 30, 60, east, 120, 150 and south. In this case, it will become north, south, then from the center 20 degree angle. So, instead of drawing from north 30 degree angle, I have to draw 20 degree angle. Let us do for a few of the numbers. So, you see, instead of 30 degree, I have drawn an angle of 20 degree. So, I write here 20 degree north. Next, one has to write 40 degree north, 60 degree north. East will not be there because we will get then 80 degree, and finally we will come to 160 degree north and then 180 degree north. And then the rose petals are created, then fill up differentially these petals. A question may come, why have we used the half circle in case of the Rose diagram? Why not the full circle? Students can pause for a while the video and think and then see the answer. I hope you paused, you thought something, and let's check. Let's take the first Rose diagram. 0 to 30 degree, we drew the equivalent radius and shaded it. Now, we have taken only one number of the trend value. Whenever we write the trend, it can be x degree dash 180 degree plus x degree. For example, I can write 30 degree dash 210 degree. All these numbers we have taken 180 degree value or less than that into consideration. If we had taken values intentionally either 180 degree or more than that, we would have taken all these values. Now, the line, let us say line M remains the same, but instead of taking the lower value, I take the higher value. Then I would have got over here a similar petal of the rose. Now, size wise these two petals are the same, and since it is a repetition, to avoid ink, to reduce the printing charge of the rose diagram, we are producing only half of it. But nevertheless, there are some cases in the geological literature where the full rose has been used. That means a circular presentation where 0 to 30, 30 to 60, 60 to 90, these values, and not only that but on the opposite directions also the petals are drawn. Under what circumstance it is required, we need to understand. We started rose diagram with these kinds of lines where we did not have any specific directional connotation. Whatever be the line, this line can indicate either this geographic direction or that geographic direction. We did not specify. Only in such cases where just lines are given and no specific directions are indicated, which means two possible directions of flow or movement is indicated, we go for these kinds of half circular rose diagram presentation. But consider a paleo flow direction. The river has flown in the past from west to east or east to west, northeast towards southwest, etc. In that case, a single direction will become important. So, take the case of line 1, this I am drawing here separately. Suppose this is specific geographic direction of flow, then from the north direction this angle we will take, and suppose in line 1 or parallel to that there is a line 5 where this is the exact geographic direction, then from geographic north instead of this angle I must take this angle. So, you can see a line is no more having two possible directional connotation, it has got a single direction in this case or in that case. And how to measure the angle? From north in geographic clockwise direction, this angle becomes important. That means from geographic north in a clockwise direction, let us say x degree is the paleo flow or the paleo movement has happened. And in this case line 1 and line 5 are parallel to each other, but the flow has been in this direction. So, from geographic north I have to take this obtuse angle, that this y degree angle is important. So, even though the line 1 and 5 are parallel to each other, the geographic directions are 180 degree apart, and in that case instead of taking clockwise from north direction and the lowest number, I have to take exactly the x degree and the y degree. X degree is less than 180 degree because this is 180 degree, it is less than that, and this y degree is certainly more than 180 degree because this is the 180 degree or the south direction. So, in such diagrams, if it is translated into the table 1, the numbers can vary from 0 to 360 degree. It need not be restricted to less than or equal to 180 degree. Now, using such data set, I have to go for full circle presentation of the data. So, to do an exercise, I would request the students to draw a rectangle, take 31 randomly drawn lines. Randomly drawn does not mean lines will be mutually parallel like that, try to be random, and then mark them number 1, 2, 3, then put some arrows. This line has two possible directions, give a specific direction, and then work for table 1. Your data set must reflect the number varying from 0 to 360 degree, and then go for such a rose diagram presentation. By searching in internet, you can easily find free software using which one can create the rose diagram. So, it is also students essential exercise that based on this data set that the table 1 was created and then the table 2 was created, use this table 2 information using software to come up with a rose diagram. In software, when you create the rose diagram, you will find we are not getting these lines as the circular arcs, they may become straight line. Strictly speaking, these are arcs and they are not straight lines. Also note down the name of the software. Can we create a rose diagram not starting from 0 degree and ending at 180 degree, rather starting from say east and ending at west. Have the range of trains in this way 90 to 110 degree. So, to do this exercise, and it is important and students must do with their hand on paper, not just using the software directly, that you start with the same data set and you have already table 1. Now, from table 1 you create the tally 90 to 110, how many data set are there. So, 145 I cut over there, somewhere there will be a tally over there. In this way, create the tally, create the frequency, find out the equivalent radius, and then again you draw these petals, fill up differentially and create this rose diagram also.